Hello there. Am I streaming? Excellent. Great. So, in this stream, I wanted to explore a tiny bit the Mlock syscall, which allows your memory to not, which allows preventing, I don't know how to speak English anymore, but it prevents some memory page that you define to go into swap. So that if you have a real-time application, the memory, never gets slow or anything, or for security reasons, you don't want, if you're manipulating passwords or something, those information to end up on the disk accidentally. And the other thing I wanted to explore is a schedule, just sked or something. Yeah, there is the whole CPU scheduling on Linux, and I was curious how this all works. So anyway, and maybe other topics if I feel like it. Let's see. Let's just start with Mlock because I think it's gonna be slightly easier. Mlock, let's see, Mlock. Alright, let's create a main. Boom, boom, boom. Like so, like so. And is it still... Fuck, I'm streaming my face. There you go. Well, it's not like you missed anything. I just created the file. So, yes, main up stdio. So where does Mlock live? Let's see, it lives in sysman. I don't know why it's called man, because this is also for mmap. So it's like memory management. Oh, memory management. Oh yeah, that's it. Maybe. I don't know. Include sysman. So and so we can just mlock something, mmap something. I meant mmap. This is gonna be null. Here we're just gonna pick, I don't know, one page, because that's gonna be easy. We can do prot read, prot write. Here we can do map anonymous, like so, and map private. Hello, how are you doing? How are you doing? You don't know me. Map private, and I think that's it. Then there's a file descriptor, which can be -1, and an offset, which can be 0. Oops. Let's undo this. And unmap here of data. So that's correct, right? I'm unmap. Doing well. What about you? How's yeah, life's pretty good. Yeah, not much. I'm more established in Switzerland, I guess. Just living life, doing YouTube. Nothing special. So anyway, we have some memory allocated, and then we're gonna lock that memory with the data and the size, which is just this. Sure, there is some other version of it, but that doesn't matter. Unlock. Not sure if you need to unlock after. Unlock and perform the converse operation, unlocking part of all of the calling process virtual address space, so that page in this can be swapped out again. Okay, this doesn't seem all that interesting. And let's just do data. I don't know. We place some... we have to convert this to maybe a car pointer. like so. So let's just set some data somewhere. Well, actually, let's just set it. Data to a this. And memset is in a string.h, like so. So anyway, we're doing stuff. Let's see that this compiles. Yeah, it obviously does nothing. And so how can I showcase this? I think I should make a container which would have like maybe half a gig of RAM and half a gig of swap. And then I would need to allocate multiple M maps and just have some of them locked and some of them not locked. Or maybe I just have two versions of this process, one which doesn't lock the memory and the other one which locks it, and then we compare performance and we should see that the one who locks it never goes to swap, and so it's much faster. Yeah. That seems better. Let's just do define iterations, like so. We're gonna say 1,000 for now, and we're gonna say for int I, while I is lower than iterations, I++, and we're just gonna set the memory to, I don't know, something like something like this, just so that it the process should last longer. Then let's see, docker run rm, then we can do alpine bin sh. Oh yeah, right, I have to do it to have a terminal. Then we have an alpine container. I guess this doesn't give us the thing, so we can add a htop. And by default, it has all of the CPUs and all of the RAM, and it also has the swap. Okay, well, let's search how to limit. Well, I know it's the resources. How do you change the resources on the command line? Help me, please. No, that's not what I wanted. I wanted a run help. So there is the ulimit. Maybe I think it's resource. Nope. Memory. Oh, there you go. Memory bytes, memory reservation, memory swap. Oh, that's exactly what I want. Nice. I guess we don't need to limit the CPU, so it's just memory and memory swap. And then there is memory swappiness. Huh. Yeah, I think it's like a value that determines like kind of a priority for like which memory can be. Or no. It's just like a memory for the kernel, I think. A value for the kernel to know like how much it wants to swap, I think. Not sure. Okay, anyway, let's just start with memory and memory swap. Like so, we can do memory is gonna be, I don't know, let's just say, I think it said it's in bytes, so let's just do something like a, I have no clue, but let's just do hundreds. Is that correct? And 1, 2, 3, 1, 2, 3, that seems okay. That's 1 million, right? And memory swap will be 1 million as well. minimum memory limit allowed is 6 megabytes. Okay, sure. Well, let's have the minimum one then. Is that correct? Or can I not count anymore? Okay, anyway. Yeah, I guess since it's in this unit, it's multiplied by 8 or something weird like that. I should really learn the proper units. I mean, this is in bytes. Oh, but wait, if it's in bytes, and this is in bytes as well, then I don't see why. Maybe. Wait, because I feel stupid, so I need to know this. Is that it? No, okay, there is something else. APK add htop. Oh, I'm guessing I need more memory. Okay, fine. Let's just do something like 10 here. So that's 1, 2, 3, 1, 2, 3. That's 1 megabyte, and then let's do 1, 2, 3 here. And let's do 1, 2, 3, 1, 2, 3, 1, 2, 3. So that's 1 gig, or it should at least. APK add htop. APK add htop. Great. So, oh, that didn't work at all. Okay. I still need to finish your advanced C series. Go to episode 20/40. Yeah. I think the most interesting ones are at the beginning anyway. If I am not mistaken. Oh, that's me. Let me check. Maybe I can avoid you wasting your time. Well, no. I guess regular expressions. Yeah. I guess there is less important stuff like context expert, static asserts, complex numbers are also more optional. But besides that, well, this one is fun. Yeah, besides that, I think it's good. Actually, the 40th one I realize now is one of the most important concepts. Should probably have thought of that earlier, but oh well. How to limit memory of a Docker container. Resource constraints. Yeah, that's what I did. The maximum amount of memory the container can use. Oh, you can do this. Uh-huh. This is strange. Why do I have all the memory? Is it like a different unit? It said bytes. Here, memory bytes. Memory soft limit. Memory swap limit equals to memory plus swap. -1 to enable unlimited swap. Memory swap. Yeah, sure. Let's ask the clanker. Oop. I don't think there was anything particularly critical in that history, but how to limit memory usage of a Docker container? Yeah, that's what I did, but what is M? That is what I did. Megabytes, okay. Maybe, sure, we can do 1 gig, 1 gig, and then, yeah, I still have the 32 things. It says 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay, so the limit is correct, but the limit... Uh-huh. I would like to see it with 3. Yeah, because, okay, the limit is there, so it would work. I don't even know what Docker does. Really? I mean, it's just a virtualization thing. It's just like it's kind of, yeah, a VM, but slightly better because it can run, uh, how to say, like the virtualization is less slow. It just separates one process from the other process running on your system. And you can just, yeah, kind of decide what limit it has or what files and directories are mounted to into your container, and so on and so on. I mean, you should probably learn. It's a very relevant technology nowadays. Sure, it wants me to mount some stuff. Oh, apk add btop. ETF force. Sure. That is still not correct. Ah, damn it. Okay. Well, can I just do my example regardless? So I have a limit. So if my process goes over this limit, it should end up in the swap, right? Let's see. How would I test this? Can I do something like this, but then I would have a volume, which is my a.out to a.out, like so. And then if I run my a.out, what do you mean? Bin sh a.out not found. Are you on crack or something? What are you building? I'm just not building much. I'm just trying to understand the Mlock syscall in Linux, which should prevent memory from going into swap. So right now I'm currently trying to just create a container with 1 gig of RAM, and yeah, trying to see if this actually works. Like if I try to allocate 2 gigs, there is no more space, and so it should, I don't know, return an error or something. But right now I'm mounting my little test executable in the container, but it doesn't like it. Well, I could do something like maybe wd to src, like so, and maybe I could run this in detached mode, and then I can do docker ps, and then there is this weird thing. Which one is it? 3 seconds ago. Yeah, looks like this one. Oh, it's noted above as well. And I can just docker exec into it, into that guy, bin sh. Okay, and if I go in src, okay, I have my main, and this doesn't work for some reason. I don't have gc apk add gc. Let's just compile and run it in the container directly, I think. gc main.c. What? Okay, Alpine is maybe too minimalistic. Docker stop like this. I'll just kill it. Maybe chmod is required. Oh, okay. You are maybe right. Yeah, it's not that guy, it's the other one. 0.15. Oops, like this. Well, so this executable. And yeah, it says just not found, which doesn't make sense to me. Is there a VI on this? Uh, mm, yeah, that works. Huh. Okay, let me just switch to Ubuntu because it will make it much easier. Yeah, and I assume you can just install. Or can I do this on my own machine? Yeah, no. I think having some kind of virtualization is the only way. So can I do this? But instead of Alpine, I just do Ubuntu, and I just have Bash, like so. 1 gig should be enough for Ubuntu. Docker exec, and it's gonna be. Can I just do 6? Oh yeah, I can. Let's go. CD src. Oops, CD src. Yeah, accept. Okay, anyway. Can I do this? I can. Okay, that's good. Well, can I do it is one thing, but can I do like printf hello? And can I gc main.c, gc not found, apt install gc, enable to locate gc. Great. So I would have to do something like gc main, like so, and then go back in the container and execute it here. Okay. Well, it's very clunky, but as long as it works, I don't mind that much. Okay, anyway. Yeah, so we still cannot see that we are limited to 1 gig of RAM, but we are, right? If we try to this to cut the C group for memory, we can see that's 1 gig. 1, 2, 3, 1, 2, 3, 1, 2, 3. Yes. Okay. Okay. So can I do something like what is the return value of Mlock? Could not be locked. This. No memory. Okay, so I should do int ret, and we can do if ret is different than 0. On success, this system call return 0. Yes. Return 0, we do p error mlock, like so. Yes. Let's compile it. Let's run it. Okay, so there is no error. That's good. So it was able to lock it. Let's just have a little print here that says locked. Yes, okay. Okay, and now let's just yeah, require more memory. And what should it be? Like I have 1 gig of RAM and 1 gig of swap. So can I just do 1.5 gig, and then like a third of the thing should be swapped? And so this is megabytes, this is kilobytes, and this is just bytes. And let's replace all that by size. And here, yeah, let's just keep like 4000 because I don't want this to take forever. Cannot allocate memory. Aha, so the mlock failed, but the error message is strange. What if I don't log the data? Is it all good? Like, can I do if data equal map failed, then we print an error. Like so. Okay, nice. Are you French or Swiss French? I'm neither. I'm Belgian. So yeah, they also speak French in Belgium. So that's my native language. Do 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 do. So, but I'm a French speaker in the German-speaking part of Switzerland. So you can see I'm efficient. Could have made life easy for myself, but yeah. But to be honest, I prefer the German part, or just the like general Germanic part of Europe is. I think it's better than the what Latin part, like French fries and waffles. Yes, 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 and beer, mainly beer. So anyway, that kind of proves that it works. So I can mmap the memory, and it will use some swap. Can I make it sleep for a while so that we can actually see that? Just sleep for 30 seconds. Std lib, I think. Yeah, .h. Fine, it's not that. Where is sleep? It's uni std, really. So it's gonna sleep for a while, and I should see on my system that some swap is used, and it's not. Huh. Why are you studying OS? I don't know. Just got curious. Seems fun. I was already into like just low level programming stuff, and so I recently just basically I don't know. I just did Man 2. Man 2 is where the second section, so that's where the syscall lived, and then I did tab like this, and then I was like, oh, that's a lot of stuff that I don't know, and so yeah, I just started going over them, yeah, one by one, and seeing which one are interesting. And yeah, I've discovered a lot of performance-related things that you can do at the operating system level, so it's quite fun. Swiss German are Karen's life there is joyless. Really? I don't think so. I think they have fun here. I don't. Well, I mean, I don't speak German, so of course, to me, like I don't have I don't have much human interactions with people, but I think that's just me. It's not the people. So far, I don't know. Every Swiss German person I've talked to, like at work or something, has been very nice. So yeah. I think I had this cliche in my head before I came to Switzerland, just because I don't know. That's what the internet said, but it turns out it's not true at all. So yeah. Uh, mm, mm, mm. So too many rules. Oh, well, that's Switzerland in general. Well, yeah, that's true that there is a lot more rules. But I mean, it works. I mean, when you see the state of the place. It's very nice. So, I mean, once you learn the rules, it's easy not to break them, you know. So how can I demonstrate this? Also, why is it not going to swap? Like, it's very annoying that I don't have the TTY thing. Can I just do bash? And then I can... And then... Oh, okay, nice. Everyone there is the police. I mean, come on. I have a feeling that you're either French or Swiss French, but yeah. I mean, it's not that bad. How am I supposed to show the stuff? I want to show that this is going to swap. Let's ask the clanker one more time how to show swap usage in a container. Think, clankers, think harder. Okay, there we go. So this is the current usage, and this is the max, and the max is 0. That's not good. That's not what I want. And and to show the memory max, it's this. How come the swap max is 0? Docker run help memory swap limit equal to memory plus swap -1 to enable unlimited swap. Tune memory swappiness. I'm guessing okay, I think since I set them to the exact same value, this means that there is 0 swap. I need to set the swap above the thing. Or another thing I can do is just have unlimited swap. So it was 6, stop 6. I don't know why it doesn't stop faster. Yeah, anyway, let's consider it stopped. Let's run it, and we'll have the memory swap to -1. Or maybe just 2 gigs. Something like that. Oh, because I run a terminal on it, that's why it doesn't stop, maybe. And then exec on 51. Let's go back in there. Let's do bash. cd. Don't I have src? Yeah, I do. And if I go here and I I recat the swap limit. Give me the swap limit. Give me the swap limit. Boom, 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 boom. Aha! Now we have a swap limit. That's good. Although now I don't understand at all why this allocation worked previously, because I only had 1 gig of RAM and 0 swap. So how is it possible? Oh, maybe I need to actually do map populate. But that's just a hint. That won't change anything. Well, let's go back to this temporarily. Let's just do gcc main. No. So, okay, that works. That works. So what I want to see now is that I want to sleep. Yeah, 30 seconds should be enough. I need to do docker exec. It was 51, I think. Let's just do bash. src, and we want to get the current swap usage. Oh, it's already using some swap. What the fuck? What are you doing? Can I memory current swap current 1 2 3 1 2 3. That's only 3 megabyte and 1 megabyte. Oh, maybe that's just for some metadata information. Okay, well, let's run the thing. Okay, let's run the thing. So now it's using memory, and we should see. Ah, there we go. Okay, good. So now the RAM is maxed out, and so we're going into swap. Great. Great. Although, I mean, if I'm making a video about this, I don't know, this looks ugly. I would have wished for an htop kind of thing. And also, I'm not even sure. Okay, so now it's stopped above, and if we go, the memory is back to normal, and the swap is back to, well, slightly higher, but it's way less. I don't know. Huh. Yeah, the thing I was wondering is that is the swap on this even real? Like, is the swap in the container actually just RAM on my computer? Let's ask the clanker. Is the swap in a container actual swap of the machine? Yes, container. They use the host swap space. Okay, let's do htop on my machine. Well, htop is maybe ugly. btop. I mean, okay, fine. So anyway, there is stuff. There is the memory. Where we can we see the swap? Oh, we can see the swap here. Okay, 0% used. Okay. Let's see. If I do this, the swap is used on the container, and here it's used 3%. I think. Okay, but that's good. That means that it's currently using it. I think. If we wait until this quits. I don't know why I put 30 seconds. That's kind of boring. Oh, I think it stopped now. It did stop, and we did see that it went back to 0%. So I think this is correct. Yeah. Okay. So now I have a demonstration to show that it works. That's already good. Let's just save this inside of I don't know, start container.sh. Let's just save this here, like so. Let's put those in evidence, like so. Let's put the rest on the top. Like this. Okay. So that I remember how to spin up this. This. Oh. Ah, fuck. My chat auto-translates the French things to English, and it does a terrible job at it. How can I disable that? This is very annoying. Because there is a guy that says Neovim question mark, and in my chat it shows up as why question mark. So apparently there is some language where envim means why. Can't. And this is so bad. Why does YouTube do this? Why isn't it an opt-in kind of thing? Why do they force this on me? So stupid. Anyway, someone said hi, so hi to you. But with the translation, it shows as this. Literally the word this. So great. I was a bit confused. Like, yeah, this guy is just saying this randomly. Okay. So anyway, now I can show this. Let's modify the main. Let's modify the main to have 100,000 iterations instead of the sleep, and we're gonna have a size of what? Like 7. What is this even? Can I do this? This is 700 megabyte, and so if I start two of them, yeah, the one where the memory is locked should have the memory, and the one where the memory is not locked should have the thing. Okay. So let's just have this. Why is size wrong? Oh, right, because I just have this. That's fine. That's fine. Anyway, there is a bunch of iterations. We write the thing. Maybe. I wonder if this will use it though. You can use. No, you cannot. This is for Python. You cannot use this in C. In C, the separator is a single quote. But it's only in C23. That's why it's complaining. But I can just do LSP. I think I could do LSP stop like this. That's it. C# guy. Oh yeah. Well, I think these kinds of stuff happened after all the language diverged. So yeah. So what do I want to showcase? Oh, I need one executable which locks and one other which doesn't lock. So let's just simply have a little argument that will say if argc is equal to 2 and argv1 str compare this with mlock is equal to 0. We can do this. So gcc main.c, and I would like to, I guess I can just use the time built-in to time the executables. So let's do that. But I have to start them at the same time. Kinda not. Okay. I think if this takes long enough, I don't have to. So can I do exec this? Is it still running? Yes, it is. So let's go nsrc. And we can remove foo. And we can do out with mlock, like so. How much? Cannot allocate memory, really? Why can't you allocate memory? Oh, it's not that it cannot allocate, it's just that the mlock failed. Maybe that's too much. I wonder why it's too much, but I don't know, let's just try less. What about something extremely tiny? Like 500k. Okay, good, except that's too fast. So let's do more iterations. That's what? That's 100 million iterations. That should be plenty, no? Okay, does some stuff and it quits. That's still not long enough. Let's do this times 5. Ta-da-da-dum. Okay, except maybe this is slightly too long, so let's do, I don't know, let's do 3. I have to come up with a time for the benchmark, which doesn't take too long to bore the video, but isn't too short to not be a good benchmark. How interesting the life of a content creation. Okay, and so now I have a time, which is 5 seconds, which is good. So the thing is, I'm not sure. Like this is too tiny. Let's try something bigger. Well, let's try it until. Okay, so that failed. I forgot to do exit failure, like so. I don't know, it's not what I wanted, so this is already too much memory. I'm not sure why. This is only 5. I'm supposed to have 1 gig of memory. This, so it's locked. And it does stuff, it takes exactly the same time. Let's do 10 and see what happens. Oops. App cannot allocate memory. Okay. I mean, this is very boring, but I don't understand why I cannot lock that memory. Okay, 7 megabytes seems to be okay, but how does that make any sense? Like this container has 1 gig and I'm only allocating 7 megs. So what does the man page say about this? Oh, I forgot I can kill this. So it's in return value and it should be a nomem. Okay, some of the specified address range does not correspond to mapped page in the address space of the process. What the fuck does that mean? Some of the specified address range does not correspond to mapped pages in the address space of the process. Huh. Ha ha ha. I mean, that doesn't make much sense. That doesn't make much sense at all. Well, let's try to benchmark it anyway. I'm sure it will fail, but so what we will do is docker exec, like here, and then I will time a.out. So one will have the mlock and the other one won't have the lock. So let's do this. First the lock. Oh, right, well, that's a failure. So once again, first the lock, and the other one which is not locked. It's about the same. Yeah, that's to be expected. What if I do mlock both? It can lock both. Okay, so I do have to fix this issue where I cannot lock more than this. Huh. What if it's just the fact that it needs to be a page multiple? Like so. Except that we would need to remove this, and then it would be slightly reasonable. Let me quickly compile this, like so. Maybe I could just have something like gc. Let's see here. Great. So, cannot allocate memory. What the Let's ask the clanker. Plenty of memory. Is limited by... Oh, there is a U limit for this. Oof, that's a lot of text. Max locked memory in kilobytes. Ah. Okay. Okay. God damn, there is like 50 different limiting things in Linux. There is like the U limits, the C group, the C group version 2. God damn it. Okay, how can I raise this to just be the RAM? Okay, I have to use this. So how can I see the hard limits? Okay, this is too many flags. Okay, let's just do this. Okay, start, no, docker run. Except that I need this ulimit flag now. Yes, and so we can go back in docker exec and do d4, like so. And here as well, we can do d4, like so, and ulimit all. And now the max, oh, you can't see because there is my face in the way. Ulimits all. The max locked memory is unlimited. Great, finally. So src, and then we go cd src for this guy, and we can go back to having a humongous amount of memory, which can be, I think I picked 1.5 gigs, which is 123, 123, like so. That's correct. Yes. And so, no, this is just, oops. Let's compile it. Let's do time a.out mlock. Killed. What? What do you mean? Where does this killed even come from? I don't have anything. Okay, maybe that was too much memory. How about, well, how about the not mlocked version? The not mlocked version works. Oh, which makes perfect sense because I think, well, no, I mean, I would have expected a failure here, but okay, maybe my system also has a U limits A. Maximum stack size. What's the fucking locked thing? Ah, there is a... But Docker is root, so I assume you can bypass that. Okay, let's try something smaller. Just 700 megabytes. So if I spawn two processes, one should be, the one locked should be in RAM, and the other one should be partially in swap. Let's do this. Let's do, oh, I forgot to compile. Like so, yeah, just locked. Okay, great. Great. Now we are gonna have to time them. So let's time this guy, and let's do the same here. Time a.out. No, executed a.out. So the mlocked one should be slightly faster, although I only write 4000 bytes. So if those are not swapped, my whole thing is useless. So I think I will have to fix that, but let's try it anyway. 5 seconds indeed. I think this is bad. I think we can overwrite all the memory, and instead of having 3 million, we can just, or like whatever the number was, we can divide it by 1000, which should yield similar times. It was 4000 before. Yeah, let's try it. Like so. Let's just see how long it takes. This is too slow. Let's just do 3000 times. Up. Oh, I forgot to compile. Okay. This also takes too long to go to... Yeah. What about one iteration? Is that okay? I mean... Okay, one iteration is not okay, so... What was it? So this would be 1 second, and then 50 should be 5 seconds, right? Okay, let's see. Okay, 2.5, close enough. I'm gonna push it to 100. Okay. Like this, and so we're gonna have one with mlock, one with not mlock. 5 seconds. 10 seconds. Let's go. Okay, that's nice. Hello, how are you doing? Does it work if I do it in the opposite direction? Can you see the result of the benchmark? Yes, the camera is not in the way. Let's do the same, but this time I will start this one first. I don't think it matters too much, but just to make sure. 5 seconds again. How about you, my guy? 10 seconds, let's go. 11 seconds even. Okay, well... Yo, bro, why you kinda... I don't know what you mean. I don't know what you mean. I'm well. Yeah, I'm pretty good. How about you? How about you? I'm currently looking at how mlock works to lock the memory and preventing it from going to swap. So there was, I forgot, I need to add this to remember that I need to have this ulimit flag. Whoop. Up. Alright. GigaChat 42 stolen builds OS from scratch. Well, actually, I have a project. I do have a project called Little OS where I do build an OS from scratch. So there you go. The meme is confirmed. No showers allowed before project is completed. Indeed. Well, no showers allowed at all. I mean, I don't even know why you would shower. That's just a waste of time. I think the stronger you smell, the more you repel people, and so you get less distracted people because people come less to you. So there you go. Great technique. By the way, the OS project I showed is not finished at all. I really need to, dive more into it at some point. I just did the introductory stuff where, I don't know, I just just print the character to the screen, but with your own kernel kind of thing. Which is a shame. I think I should dive a lot deeper. It seems quite interesting. The words of a man, not a child, indeed. Indeed. Never shower, kids. That's my best advice in life. It will also train your immune system, so that's great. Alright, I have my example for Mlock. I mean, and so let's just confirm that. So if I would do both without Mlock, I assume they would both take around 7 seconds. Not sure. Because, yeah, if this one takes 5 and this one takes 10, then, I mean, it's a bit ruined. How do you learn? I'm actually new to computer science, starting college this year. There is so much. How do you learn? I would say practice. Yeah, like, I mean, it's cool if you watch my videos and so on, but I would spend most of my time doing stuff, not reading stuff or listening to videos or something, especially as a beginner. Because I don't know, once you have a bit of experience, like watching a talk or something on a very specific topic can be great. But at the beginning, yeah, just do stuff, do a lot of stuff. Yeah. Hello. I guess pick something to learn. There is so much computer science to learn. Yeah, I mean, you don't have to pick. Yeah, I mean, you don't have to choose a specific thing. You can just do something one day, do something else the other day. There is no rules, you know? You can just learn whatever you want. So yeah. And eventually, when you're not so new, like, I don't know, after a year or something, I would recommend just starting looking at what interests you the most, and then you kind of narrow a tiny bit your search space for knowledge, and yeah, at some point you start to target a career, and then you narrow it even more on that career, and so on and so on. And if you're ever unhappy, you just widen the scope again for more fun stuff to learn. I don't know. I have a real question. How do you find the drive and energy to do stuff like that after work? Personally, I love CS at the core. I work in cyber pure ops. What the fuck is cyber pure ops? That sounds like your work is a is part of a video game, my dude. Sounds like I don't know, some title from Cyberpunk or something. But it's not like academia anymore. Yeah, I don't know. I work in SecOps. Just security, like people. Like you do the security of infrastructures and so on, I assume. Security, incident, corporate security. Oh, okay, I see. Yeah, I don't know. Depends on on the people. I think there is some people they just enjoy school, and then they get a job, wife and kids, and I don't know, life just changes a bit. Uh, I mean, if your job is boring, then I would go full on into your hobbies. Just, I don't know. You have to have something in life. I mean, not even computer science, I don't know, it can be sports or whatever. Or, I don't know, chess, whatever. Some kind of hobby that brings you joy. But, yeah, for me, The voice isn't working well. Really? Well, let me check. Let's see. The voice isn't working well. Really? It's working fine for me. I mean, I don't have the best microphone or audio setup, but I think it's audible, you know? If I want to make my OS, where should I start from? Oh! I have a website for that. Little OS. No, it's not that. This, I think. Is that it? God, it's so slow. It's not that at all. Wait. Let me search it. Did I at least read me? This is just my notes. Oh, little book about OS development. There, yeah, that's it. There you go. I mean, there is probably 1,000 resources, but this was great because, yeah, it's just a follow along thing, and yeah, they explain a lot of stuff, and it's not too big, you know. It's just like you don't get into like crazy stuff. It's just yeah, you get the basics, you know. And so from there, I think there is a wiki about kernel development, like not the Linux kernel, but like just kernels in general. And I think there is the best source of information. Actually, don't I have the? No, I don't have it. Yeah, it doesn't matter. Thanks. Yeah, no problem. Do you have Discord? I did. I never think I'm not on there for a long time now. Audio was stuttering for a bit. Ah, okay. Yeah, sorry about that. My internet recently got way shittier, so I'm fighting the provider on that, but what can you do? Anyway, I think that's all for Mlock. Well, maybe one thing to try. One thing to try would be Mlock, because there is Mlockall and Unlockall. And I think this might be more useful because this just says like lock all the current pages and all the future allocations should also be locked. So I think this is more useful because, I mean, real applications, I mean, you can use mmap, of course, but they usually use malloc or some, I don't know, allocator or whatever. And so if you can just lock pages without being concerned by which allocator do I use, or like what pages are actually allocated by my application, I think this could be fun. So let's look at mlockall. Oh, there we go. Locks all page mapped into the address space of the coding process. This includes the pages of the code data stack. Aha, yeah, this is important because right now I only locked like I only locked this part of the data, but of course my stack and my other stuff is not locked as well as shared libraries. I didn't know that. Yeah, that does make sense. The code, like the code itself, can be swapped. That's crazy. Can you explain calling and virtual address? Well, calling is just calling a function, so that's it. Like p-error is a function, and you call it with the parentheses. So yeah, if I had the function foo and I do this, I'm calling the function, you know. So that's quite simple. And virtual address is a bit harder. It's like every single one of your process, like the OS pretends like your whole process has access to all of the RAM because it's just easier to organize. But in real life, you have like, I don't know, 200 processes, and all of those, they think they have all the RAM. But under the hood, there is a mapping that happens between like those virtual addresses of those processes and the actual RAM under the hood, where you just map some address from those virtual this virtual memory to the real one. And it's quite a complex thing. You can go watch my video about huge pages if you want to know a bit more. Although, I mean, if you're more interested about just virtual memory, I'm sure you can just go on the Wikipedia article and you will learn more. You're making your own OS. Well, I used to, and then it got hard, and I gave up. But yeah, it was very fun. But I thought like, I mean, making your own OS is great, of course, but like for, let's just say I started this series, this thing about syscalls, just because I was running into performance stuff at work. And I got curious about how can you improve performance of your application, but like, I don't know, just using the OS better, not just making your application faster, you know? Turns out there is a lot of ways to do that. So yeah, that's quite interesting. And I think it's also easier for me because I was very used to the application side of things, like in C or C++ or Rust. And like the kernel is a bit of a black box to me. So I think learning the interface between the two a bit better, I think this is, I don't know, the best. I don't know, it's useful for my work, but it's also interesting, and also I'm getting slightly closer to understanding the kernel, you know. So yeah, but I mean, you can do it any way you want, especially if you're currently studying or whatever. I would just feel free to dive into kernel development. I think this seems fun, you know. It was just more useful for me. Oh yeah, I didn't look at the result of this benchmark, but actually it looks okay. They were both slower because I assume there was a swapping on both processes, and so they both were slower than 5 seconds, which is good, meaning my example works. Anyway, let's do something where I temporarily comment this out, and we're gonna try out the Mlockall thing. Mlockall, like so. I plan to eventually look over the Linux man pages when it gets to summer. I need to build an OS in my next year of university. Damn, that's pretty cool. I mean, I remember School 42 also had like some OS projects, but I only did like a couple of them. Didn't go all the way. But yeah, it's very nice if you need to do a tiny OS at your school, or even a big OS. But yeah, I mean, if you're going to do that, I wouldn't go into the Linux man pages. Although I don't know what do you mean like this as man pages, or do you mean the actual kernel documentation? Because, well, I would look into neither. I would just look at some tutorial on OSs, like the little OS book like that I shared above, or some other similar thing, you know? I mean, these days you can also learn with the clanker, so just talk to it. Although, I mean, that's a bit of a, I don't know, learning like that, a subject from scratch, seems like it, I don't know, my brain gets overworked, you know. So Mlockall locks all the pages. All mapped pages are guaranteed to be resident in RAM when the call returns successfully. The pages are guaranteed to stay in RAM until later unlocked. Okay, so there's flags, lock all pages which are currently mapped into the address space of the process, all the future other location. That's very cool because you can just call this at the start of your program with the future flag, and then that means that yeah, that all of your future allocations will be locked and not go to swap. I think this is quite nice, and I might use this at work actually. MCL on fold, used together with MCL current, MCL future, or both makes all current. Yeah, this is regarding faulting. which I'm not 100% confident what it is. I think it's like if you don't use a page by default, it's not faulted. So meaning like like the OS can save some resource for it, and as soon as you write to it the first time, it gets faulted in, and so yeah, there is some I don't know, mapping that needs to be updated or something. I'm not sure. Seems interesting. But anyway, let's just use current and future for now. MCL current, MCL future. So let's no, let's not do that. Let's compile it. Okay, it does work. Let's redo the little test like so. Let's see if it also works. You work in system engineering, dev. This is often I miss this. Yeah, I mean you can. I don't think the jobs in that field are too rare. So, I mean, security seems fun as well. I'm not sure why you don't like your job, but well, I mean, it depends. Are you like patching stuff, or are you just only looking for vulnerabilities all day? Because yeah, I guess it wouldn't be for me as well. Like I prefer to do stuff than to look at stuff. Because at my level it becomes more about politics and high level management, but the pay is good. Ah, okay. Yeah, makes sense. Yeah, I was also in a big company at some point, and you often get blocked by the politics, which is very annoying. But you know, if you gotta make bread, as they say, yeah, you gotta do it, you know? Well, I mean, you can do it until you find something better, but I would really just optimize your life outside of work if your work is shitty. Because if you're in a big corporation, there is usually very little you can do about like making it better. Well, I mean you can. It will just take you like years instead of 2 weeks, you know? So I don't know. Depends if you want to invest like years of your life into this, which might be worth it if you want to climb up the ladder and so on, but I don't know. To me, it doesn't seem that fun. Okay, the example still works with Mlockall, which is kind of cool. I see. Okay, well, I think that's enough for the video that I will make at some point, so let's switch topics. Let's go here. What time is it? It's 2 p.m. Let's do mkdir sked for scheduler. So another topic I wanted to explore was the Linux scheduling things. Are you a systems developer? Well, my voice is fucked. Wait. Sorry about that. You should probably return from the main when mmap fails. Yeah, I mean, I should probably do a lot of things for error management, but this is just a small example for a video. As soon as you add error management, the stuff, the code gets more bloated, and so it's harder to yeah, showcase something. So it's just to make it more accessible for people to learn. That's all. In a real life scenario, you should obviously check for errors. Are you a systems developer? I don't know. I code in C++ all day, so I guess that qualifies. Yeah, I make a trading engine in my day job for forex and a bit of crypto as well, but mostly forex. Overview of CPU scheduling. Replace the earlier big of one scheduler. Okay. So there is multiple topics. I didn't even know that there was a get priority thing. Return the nice value of a thread. Oh, okay, that's very simple actually. Set the nice value of a thread. Aha, so this is exactly the same as nice, except that it's for threads instead of processes. Um, mm, 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 mm. Yeah, the Linux functions naming is I don't even know what nice means. Like sometimes you don't really know. Sometimes it's an abbreviation, sometimes it's an acronym, sometimes it's just plain English, but it's hard to tell. Like sched mean scheduler, but yeah, I don't know. For example, ePoll, I don't know what the E stands for. Maybe event. Not interested in the core ladder bullshit. I'm looking for my exit plan. I have too many things and avenues in my head, so it's not committing to anything right now. But I know what you're doing. You mean what I'm doing at work or the YouTube channel? Well, maybe it can be like systems programming in general. But I mean, if you're looking to get into it, you should probably, I don't know, do a lot of personal projects in that field and showcase those on GitHub, LinkedIn, YouTube, something like this. I mean, even if it's shit at the beginning, well, especially YouTube, not the projects. Like, I think it's worth it to just show the world that you're doing something, you know? Even if, like, 5 people watch it. It's also good to, like, I don't know, I forgot how to say it. It's just keeping yourself in check or something. Like, you know, like, I'm streaming right now, so I can't just randomly go on YouTube and watch some stupid stuff. But yeah, I mean, if you have too many things to explore, I would just narrow the scope and focus on one at a time. Like, just focus on the one that excites you the most, and you go all the way on it. So to not just also completely scatter yourself, especially if you already have a career and you finished school and so on. I think like the time for very broad exploration is over, and in my opinion, you should probably just I don't know, commit to one or two things and really go all the way on them and see the result. Accountability, yes, that's it. But anyway, let's talk more CPU scheduling. So, is your YouTube channel sustainable? Could you live off of it? Not a chance. Not a chance. I made, I think, 180 francs in 2 years with it. So there you go. Your full, oh, sorry, full revenue leaked. So yeah. I haven't started college yet. Oh, well, then you're probably very young and you should explore 50,000 stuff. But yeah, also at the very beginning of my YouTube channel, well, not beginning, maybe like after I was approved to put ads on the video, like I was like, yeah, I'm not gonna make any money off of it, so whatever, it doesn't matter. So I disabled the ads everywhere. But it turns out, like if you disable the ads, YouTube just puts the ads anyway. The only difference is that they get all the money and I get none. So it's like, I know. So yeah, now I've enabled the ads, but please feel free to use an ad blocker and give me no money. I really couldn't care less. I would be actually happier if you use an ad blocker and your brain your brain feels better because of it. Okay, there is many different things to explore. So affinity is to define on which CPU a process can run. Then there is the scheduler, where there is multiple schedulers available from us. And I think there is one that is very interesting, which is the FIFO scheduler, which is basically a real-time application where your process takes over the other ones. Maybe though, maybe it would be much more interesting to just start with nice, because it's that simple. Well, most people know about it, but I mean, still good to showcase, I think, right? So, okay, and I have to know now, because somebody mentioned it, what does nice mean for the nice syscall? Nice refer to how nice a process is to a high. Ah, so it's literally the English word nice. So the higher your niceness, the more you will allow other processes to take over your time because you're a nice process. And the less nice you are, the more CPU you grab to yourself. Okay, I mean, it's a bit weird. It's kind of funny. Int main, let's just do something very dumb, where I just have I don't know, what could I have? Just a loop that does stuff. Just sum, sure. Let's do sum plus equal I, something like that. And this will for sure overflow, but doesn't matter. Define iterations, let's say 1 million. Great. Include stdio, like so. Does this take any time? Not at all, so let's do more iterations, except that this needs to be a size t now. No, oh, right. Okay, now this takes time, great. Yeah, programmer humor, it's great. Yeah, it seems like computer science was a bit more fun and free in the 70s, whenever they created Unix. Most Linux names are confusing till you learn what they do. Yeah. Well, I mean, some are fine, like read, write, and so on. But yeah, some of them are quite strange. What was another one that was, I think like pipe is a bit strange as well. Or like the T command. Like I learned this recently. I thought tea was just a joke on like literal tea that you drink, but apparently there is a thing in plumbing where if you have just a pipe and then you have a T junction, it's like a T junction. Yeah, it's this. So this is a T. So that's why the T command is named T, because you're kind of taking input and putting the output in two different places or multiple different places. Maybe they should have called it what is it, a manifold? Yeah, maybe they should have called it a manifold. But anyway, maybe it's too long, so T it is. Fork, yeah, fair enough. Fork. Well, I mean, fork is like not a literal fork; it's like a fork in the road, you know. But yeah. So anyway, let's make argc and argv like so, and then we're gonna have nice niceness is gonna be equal to atoy of argv1, like so. Oh, there is no atoy. Oh, there is atoy. It's just in stdlib. Up, up. Segfold. Why segfold? Right, because I didn't specify something, so I need to say 2. Great. So maybe this should be slower. By 2 places, you mean 2 places in memory. Was that related to the T command? I guess. No, I mean 2 places is 2 different file descriptors. So if I say echo hello, like this will be put in one file descriptor, which is stdout. And then if you T it, so the input of T will be this word hello, and then you can T it into a file. So let's say foo.txt and stdout. So what it will do is that it will forward hello to the stdout, but it will also create a file foo where it will put the output as well. So it just, yeah, duplicates the input and puts it in multiple different output. Just like awk makes no sense until you start being angry and then actually learn it and love it. Yeah, awk was pretty nice a couple of times, but yeah, I still think it's a bit, now it's slightly outdated, I think. But like the full language, like it's, of course it's handy sometimes, but like the whole language is kind of outdated, I think, nowadays. Except if you like it, if you, I mean, you can still learn it. There's nothing wrong with that. I had a funny thought that echo should be named argsx because echo, params output, and args. Oh, yeah, that does make sense. That does make sense. But they love to do this thing where there is cat, and then there is a tac, you know, the reverse of cat. So it could be xargs and sgrax. It could be sgrags. Yes. So let's replace all echo command with sgrags. That will surely be very nice to learn for newcomers. I'm sure they will love it. So let's do this. Yeah, I forgot to call nice, so I should do call nice, niceness like this. And nice is in uni.std, so uni.std, like so. Yeah, it takes a bit of time now, and should put time on it. Okay, and I doubt I can benchmark this on my machine unless I spin like I don't know, 32 of them. But let's try anyway. So let's have one process with a niceness of 19, and I think the limits are like minus 19 and 19, if I'm not correct. And so the higher the number, the nicer your process is, and the nicer it is, the more it will let other processes walk all over it. That's one way of saying it. And so let's just do those at the same time. So this doesn't make any sense, of course, because the one with the higher niceness completed more faster. I doubt this will change. So I think I will need to create a little Docker container with only one CPU available. And then I will redo the same test and we'll see. You do CUDA GPU parallel programming too. Well, not at work, but I dabbled in it a tiny bit for, I think it was just displaying the Mandelbrot set. Cache Mandelbrot. Yes, so I had a little Mandelbrot visualizer, which I did using CUDA, I think. Oh, never mind, I use OpenGL for it. So yeah, that's the extent of it. I also had a CUDA. Yeah, I don't know. I did some stuff in CUDA. That's not all of it. But anyway, I was learning the basics of GPU programming, and it seems awesome. It's just that I've never had any use for it yet. Well, I mean, besides like for fun stuff, but like in a proper work environment. Like the only GPU stuff that I need might be for running like models. And for that, I already have like libraries like ONNX runtime and so on, which already do all the work for me. Or for training, you have PyTorch and so on, all the Python libraries that also do all the CUDA stuff for you. So, yeah, for math, obviously it's very fast, but I'm trying to get into it with C++ mainly to try doing parallel GPU inference. I think I can do a fun project right now. Yeah, it is very fun. That's for sure. I'm just saying that for like the most useful stuff out there, like all of it already uses libraries, But yeah, of course, if you have I remember I had like an n-body simulation. So this is just like I don't know if you can see it on stream very well, but yeah, it's just a little gravity simulation where you have a bunch of dots and you simulate the attraction between each of them. And anyway, so this is used like in physics and so on to do some simulations of the universe. And I did all that on CPUs with AVX2 and so on. And at some point, I switched to the GPU, and I ended up on some paper that redid like the algorithm that I was using on GPU, but it's like so crazy complicated. As soon as you go on the GPU, like like you had the naive approach, then you make your algorithm, then you go to SIMD, and then you have a GPU which is like all the way in space. So yeah, it's very hard. Oh yeah, it was this one. An efficient CUDA implementation of tree-based Barnhut n-body algorithm, and the guys, they just I don't know if there is an example of the thing, but yeah, the code starts being weird. So yeah. Anyway. Super steep learning curve. Indeed. Well, I mean, if you're doing like matrix multiplication, I'm sure the learning curve isn't that bad, because that's a bit obvious. But there is if you want to get started, I think there is the obvious like map, but that's like 3 lines of code. There is reduce, which is very nice, like how to make a sum or any kind of reduction on an array. It's a surprisingly nice algorithm. And there was a sorting where you can sort in parallel using sorting networks. I think that was also a very nice one. So yeah, those seemed nice. Anyway, how do I create a... Let's do docker run help CPU. CPU period, CPU quota, RT period, shares. CPU shares, number of CPUs. Oh, CPUs. That's just docker run. Except this, we do CPU is gonna be just one. We can remove the rest, like so. No, CPUs with a an S, I guess, docker exec like so, and its container e3 like so, and then I would like to. I try to set the nice value to -19 and said operation not permitted. Oh, yeah, maybe I do need to check the return value. The range of a nice value is +19, low priority to -20. Well, I don't know what you're doing. Maybe I will do the same thing on mine, just to make sure it actually works. Like so. I think it returns -1, right? Return value, -1 on error. Straight. Yeah, seems to work. So I'm not sure. Maybe there is a U limit about niceness. Control of max nice priority. Yeah, maybe you should look into that. Just run this on your computer. I swear it's not gonna delete your entire operating system, of course. Works for positive nice value, for me at least. Aha. Yeah. Damn. I could have typed RMRF in there, and you would have run it. But I'm a nice person. Oh, wait, maybe I have the same thing as well. Let's see. Of course, positive value works, but I would. I have the exact same thing. Let's ask the clanker to change the U limit for this. Change U limit so that I can set negative niceness. I just came now. Can you? That's what she said. Can you give me an overview of what you're doing? I am currently exploring just the nice syscall to see how it works. I would just like to do a little video on it. Before that, in the stream, I was looking at Mlock, which allows you to lock certain pages of memory to prevent them from going to swap for performance or security reasons. So let's just run that. Oh no, I have to type my password on stream. That is very annoying. How could I do this? Well, actually, I don't need negative values. In my example, it will be in a container with only one CPU. So I can just have a niceness of like 1 and a niceness of 19 for the other. And then they will compete and the nicer one will be slower. Right? So can I do apt install stop? That doesn't work. I just want to see the number of CPUs available, please. Will that work? Well, we can see. Let's see. Docker exec. Was that D4? No, it should be E3. Getting confused with my containers. Okay, so this container has only one CPU available, or it should, I have no clue. Show CPU available in container. Your clanker output is much more terse than mine. I get an A4 page every question. Well, yeah, I don't know. It seems to be kind of random. I guess if you ask a very direct question, they usually respond with direct answer, but command. Oh no, oh nice. Do you also do try hack me? I don't know what is try-hack-me, but I don't do any security stuff. I mean, I don't know, I'm just aware of the basics of how to protect my application, but I'm not trying to find vulnerabilities. Try-hack-me. Certified hackerman. Try-hack-me. Security training. Oh yeah, well, I used to do a tiny bit something like that, but it was rootme, I think it was called. Yeah, there we go, rootme.org. Oh, but it's a French thing, so if you're allergic to French, stay away. But anyway, this was quite fun. I remember. If you know Tsodeng from YouTube, he would be so mad at the Docker usage. Why would he be mad at Docker? I mean, I don't know. I have to have some kind of virtualized environment, and it's the easiest way to do it. So I think it's okay. Root means something else in Australia, New Zealand. I use Incus at work. The fuck? If I'm typing some swear words right now. Oh, okay. I have no idea what all of these security things are. Okay, I'm just a regular C++ guy. So yeah, I'm afraid I can't help you much with that. So let's do a.out with a value of niceness like 1, and another one which is a niceness of 19, and I should time both of them. And go. This is a very scientific benchmark, by the way. So this one, it is less nice, so it should take... Fuck, they took exactly the same time. That's interesting. He doesn't like bloat because it's not pure, but of course, bigger footprint. Nowadays, I mostly do stuff on Windows and it's bloated over there compared to Linux. Yeah, I think if you're on Windows, it's much worse than Docker. You know, I mean Docker is, I don't know, it's fine. Depends on what you're doing, actually. If you're just doing like a home lab or like you're a infrastructure guy, Docker is very handy. But of course, if you're trying to explore the operating system and every one of your tools would be in Docker, that would be a nightmare. My current interests, C++, C, Linux man pages. Can that be an interest? OpenGL, Windows API, X windowing system, Lisp. What a need to multi-thread those interests. You cannot multi-thread interests. You are a single-threaded person, so just focus on one for 2 days and then focus on another one for 2 days or something like that. And yeah, Incus is the next generation system, container application, and virtual machine manager. Is it better than Docker? Incus versus Docker. There we go. Let's see. Showdown. So about containers and VMs. Incus provides 2 different types: instance, system containers, and virtual machines. Virtual machine use a dedicated kernel. Application container. Okay. So it seems to me like it's just one solution to choose between a VM and containers. Container runtime. Okay, I see. But can you have both? Could you have containers and VMs and kind of make them communicate? But yeah, looks cool. I didn't heard of that. LXD. Yeah, you can. Oh, nice. Okay, yeah, that's a lot more. That's a lot too specific for my application, but yeah. The seems like there is multiple CPUs available, or niceness just doesn't matter. My first internship was pen testing the most popular containers in the Docker Hub from software layer to assess container security using eBPF. That's pretty cool. That's a pretty cool internship, I think. I once exploited a Docker where Docker has shared the Docker sock as a volume and got the host machine root level access. Yeah, indeed. Well, I'm guilty of plenty of privileged true on my containers. But to be fair, I had no choice. I needed to do some stuff, you know. But yeah, Docker has a lot of security gaps if you don't pay attention. Uh, God, I don't like talking to the clinker. Create container which has only one CPU available. Thank you to all the devs for giving us work. You're very welcome. It's could you pay me a little for that? I'll create so many vulnerabilities. I'll give you so much work. That's what I did. Oh, there we go. That is what I did. And I indeed have only one CPU. How come this took the same time? Doesn't make any sense. Doesn't make any sense. Okay, but I think I will stop the stream now because I'm freaking hungry and I need to go to the gym. So yeah, maybe I will continue either after the gym or tomorrow. So yeah, see you later, I guess. If you have anything to say, it's now or never. Up. Oh, it's a shame there was still a few people in the stream. Well, maybe we can have a tiny chat section segment. Want to have interesting fun with AI? Then try Gandalf AI game. I have no idea what this is. Where you have to make AI give passwords for next level by using prompts which make increasing your prompt skills and mindset. Yeah, I didn't quite understood this, but I'm guessing it's just a kind of some prompt injection kind of thing. That seems fine. But anyway, I will go away now. I hope you all have a good day, and I forgot you can use the $ in C identifiers, although I watch your vids. Yeah, you can. That's useless knowledge, but useless knowledge is fine. Alright, see you later. Up. There you go.